Hello everyone, I am Venkatesan. This is my digital assignment for game programming where I have built a FPV drone simulator. FPV stands for first person view. This is a simulator where pilots can come and learn to fly FPV drones, that is fly the drone from its perspective, that is first person view. Basically we will be attaching a camera to a drone and using this custom controller which is commonly used by FPV pilots and drone pilots. We will be mapping that to that our game and trying to simulate the actual drone in our Unity game engine. So in this project, we will be using this uh, Radiomaster ELRC Radiomaster ELRC radio controller. This uses Express long range protocol, which is commonly used in FPV drones for long range piloting. So this transmitter can communicate up to 5 kilometers. But right now in our project, we will be using this as our uh, gamepad in our game engine. So let me turn on this
Welcome to
transmitter.
HTX. Flight mode Acro. Disarmed.
As you can see right now, we have turned the transmitter. Then we have to plug our USB cable to the transmitters, and it will ask uh, like please select the mode, and you'll be selecting USB joystick so that it communicates all the values which will be inputting to this transmitter to our system. So it basically transforms this transmitter as a joystick. So right now in my project, I have made this input system where uh, I will be processing the input from the radio master controller. We have the drone has four controllers: throttle, yaw, pitch forward, and roll. So I have made this custom input action editor, which has five types of actions. One is throttle, which is used to power up the motors, and next is yaw, which is used to rotate the drone side to side. Another is pitch. Pitch is used to pitch forward the drone or pitch back the drone, and next is roll. Next is roll. These are the four controllers. Right now, this transmitter is configured as mode 2. So throttle is here, yaw, pitch, and roll. And I have also added another flight mode as this. I have mapped this button as flight mode so that I can change the flight mode based upon the user's uh, proficiency. They can fly the drone in different flight modes and learn the various flight modes which are available in a FPV drone. So right now I have made this custom input manager, and I have passed this input manager to the drone. That drone has a drone controller drone controller script, and I also given the player input. This drone controller input is uh, mapped down here, and this drone controller script is nothing but the simulation. Oh, wait a minute. Yeah, the drone controller script is nothing but a simulation of an actual flight controller. So we can't just map this input directly to the drone. We have to do some math to process the actual input and translate various forces on the drone. So there is in robotics there is a PID controller which is used to effectively navigate across the terrains. That is one of the control algorithm. Right now I have implemented PD algorithm. So if I open the code, this is the drone controller, which has all the parameters which is defined, like the thrust force, yaw torque, all the configuration which is required for the drone, and dampening strength and stabilization. Sorry, stabilization strength and stabilization damping are act as the P and D values in the PD controller, and also used a rigid body component on on this drone so that all the other forces like gravity, air resistance are applicable to our object so that it mimics the real world drone. And we have all the functionality which has been implemented based upon the on throttle, on yaw, and all the commands on changing the values on the control that will be processed and that will be sent as forces to the drone. And next we have the camera controller script, which is which is used on the camera to follow the drone effectively, so that we will get the first person view first person view feel. So next we have the OSD controller. OSD is nothing but on-screen display. This is used to render all the information regarding the drone's uh, position, altitude, throttle percentage, all the forces acting on it. So this is my basic implementation. So as you can see, all the parameters are configurable. Wait a minute. Yeah, we have thrust force, thrust force, yaw torque, yaw dampening, and pitch torque, roll torque. All the values we can manually configure to based upon the drone's requirement, and we can also in stability mode we can limit the angle, and we can also set the P and D values of our PD controller. And these are the exposures which is used to have some dead zone in our controller, so that these controls are not that much sensitive, and it is apt to control the drone for a beginner. So these are the implementation, and right now I have implemented three flight modes. They are acro, horizon, and angle. In angle mode, the drone is 1 minute. Yeah, in angle mode, the drone is limited on the pitching angle. Say like the drone can't pitch a 360 degree, or it is limited to a certain angle. The pitch and yaw are limited to a certain angle. That angle we can also modify here, that is 30 degrees. So in angle mode, the drone can't tilt more than 30 degrees in all direction. Whereas in acro mode is nothing but full aerobatic mode, where there is no limitation of the orientation of the drone. The drone can be upside down as well. Horizon mode is something in between angle mode and horizon mode. So let me go to the quick demonstration. Okay. Okay, let me go to a quick demonstration of our project. So let me start the game. Let me pause the video. Once the game loads, I will come back. Yeah, the game started. As you can see in the uh, top right corner, you can see the mode which we are in, and the speed information and the altitude information of the drone, and the throttle percentage. So this is the implementation. So this switch controls the mode of the drone. Right now we are in acro. If I flip the switch,
Flight mode horizon. Flight mode acro. Flight mode horizon.
flight mode is in horizon, and you can also see that that is mapped in our OSD as well. Then this is,
Flight mode angle. Flight mode acro. Flight mode angle.
yeah, right now we are in angle mode. So we can take off the drone by raising the throttle. Yeah, right now we are hovering, so we can also decrease the throttle to come down. Yeah, next, as we are in angle mode, we can pitch fully, and still the drone won't tilt more than 30 degree. So for the stability, we have used this PD controller, which makes the drone as stable as possible. So even if I pitch back and leave the stick, the drone try to self stabilize itself. Next, to yaw, we can use this left joystick, and by yawing we can turn the orientation of the drone, and by pitching forward we can look down. So as I pitch forward, the speed of the drone increases because it is moving forward. I can throttle up so that I won't crash. So this terrain is right now I have implemented this mountain terrain, so which has 1,000 trees and bunch of grass. So yeah, so right now that is, so we'll go forward. So we will quickly land, and we will change the mode, flight mode. So as you can see, we have landed, but actually we are going out of the arena. So let me restart the game. Let me again tell the actual controllers. This is throttle, up and down is throttle, and side to side is yaw. This is pitch forward, pitch backward. This is roll, roll left and roll right. So next, now we will take off in acro mode.
Flight mode Acro.
So we have went to acro mode. As you can see now, I don't have any limitation. I can flip the drone 360-degree itself, and it won't limit. For example, if I'm taking this drone to like say 50-meter altitude. Next, if I pitch forward and leave the stick, it won't self stabilize. It will be keep on pitching forward, and it will eventually crash. Right. Next, actually, I can also flip the drone because right now the drone is upside down. Now, as we are in acro mode, we can flip the drone by using uh, like pitch up and wait a minute. I think we are caught in the grass. So yeah, that's also one thing. All the graphs, trees have its own colliders, so that we won't. It will be as realistic as possible. The drone can crash into a tree, and we won't be like passing through that tree. So that is one thing I have implemented. And the drone has a box collider, and other components has a capsule collider. The trees and all has the capsule collider to mimic the structure of the tree. So right now, for example, I will go to
Flight mode
horizon mode.
Horizon.
So in horizon mode, I haven't tuned that P and D values that much, so that's why it's like too much shaky. So based upon your PD tuning, so there is a concept itself in drone technology like PID tuning, where each pilots have their own PID tuning of the drone to bring the fullest of the drone according to their proficiency. Let me restart the game. We'll go into the
Flight mode
angle.
Angle.
We'll go to the angle mode, and let me try to collide with a tree. So see, you can see that we have collided and came up above the tree. So all the trees has a capsule collider, and the terrain and the drone are taken from asset store. So this, as you can see, the drone has a camera holder. Inside that we have the camera, which has the particular transformation, and it travels with the drone's position and orientation. And if I uh, change the focus mode and now start the game, we can actually see how the drone takes off from the third perspective view. So usually this game is particularly focused on first person view. If we start this game like this, we will be able to see how the drone actually flies in a third perspective view. Okay, so I'm taking off. As you can see, the drone is taking off, and you can also see the yaw motion. We are yaw left, and so I will come down again, and yeah, so we'll try to hover in that particular area. It's actually hard. Yeah, now we can pitch forward, pitch backward, roll left, roll right, and yaw, turn around. So everything is working perfectly. And coming to the compatibility, we have to actually update our device drivers in our Windows system by clicking on this, and this will install Microsoft custom joystick driver so that this controller talks with our Windows OS. So it's also dependent upon the OS. For Ubuntu or other Linux based distribution or Mac OS, the process will be entirely different. And to test the actual working of the transmitter, we can also use any online gamepad tester. Like, give me a minute. Yeah. So this system actually reached this Radiomaster Pocket transmitter. So by changing the values, that also changes in our testing dashboard. Yeah. So right now I have implemented this much. The future scope is we can actually bring much more drones. We can bring hexacopters, and we can also define various other parameters. We can also build various maps like winter terrain or junkyard or different types of terrain. Sorry. And we can also implement a PID controller and other types of controller. Basically we will be simulating a entire drone in our project. Thank you.